Lab 6. This lab is about sorting, and your goal for this lab is to write two programs, Quick to Sort and Merge One Sort. These are both programs that are talked about in the sorting lecture notes. And as you can expect, in the Quick to Sort file, you're going to implement quick sorting by choosing a partition as a median, by choosing the pivot point as the median of the first, middle, and last element. When the size is 2, you don't do the partitioning, you just sort the two elements by hand. And then you can see the lecture notes for how the middle element is calculated. For both of these sorting programs, your output should match his exactly. One of the arguments to the driver for the sorting program is to print out verbosely what's going on at each step of the sorting. So take a look at how his output is formatted, and that's how you'll want to set up your output. In the lab directory, there is a driver program called Sort Driver Lab, and it will include the main of the program, and it is given a seed which generates the random vector that's going to be sorted. If the seed is a multiple of 2000, it's going to produce vectors with lots of duplicate entries. There's also a makefile in the lab folder and sorting.h, which defines the function sort doubles. So if we look at the lecture notes on sorting, you can see the sorting.h header file. It defines the sort doubles function. So in your implementation, you're going to basically write the sort doubles function, and it's going to call another function that does the recursive sort. So if we go down to the merge sort, you can see that the function you're going to implement for the merge sort is this recursive search given a vector of doubles, a temporary vector of doubles, start, size, and an integer that represents whether or not you're going to print out verbosely the output. And you can see from when it's called what kind of output it's going to be outputting. So in your code, you're going to include the sort doubles function, and it's going to call the recursive sort function with its initial value to perform the merge sort or quick sort. Quick sort's very similar, except the recursive sort function is different since it doesn't need a temporary vector, and also the process you do for each of these sorts is going to be different. If you need any additional help with any of the sorting, there are resources such as a video that Katie Schumann put together, and also visualizers and a folk dance to help describe the sorting algorithms. Are there any questions about this lab?